We're going to be talking about solubility curves. So I am trying to do this video so that you can see as much of the worksheet as possible that you have in front of you. Well, it's not worksheet, your note sheet. So the first thing I do want you to do is go ahead and put your name on here. I have this part in case you happen to lose these notes. These are going to go into your folder that you should have picked up on Thursday. That way you have somewhere to keep them because these are just notes. You're not going to be turning these in. But what we're going to be looking at today is we're going to be looking at a solubility curve. So a solubility curve is what you see on the left. It's that graph that you see on the left-hand side. You will notice that the x-axis has your temperature in degrees Celsius, and then your y-axis over here is how many grams of your solute you have dissolved per 100 grams of water. So one thing I do want to point out about this 100 grams of water, so that you're not all like, huh? Because we don't usually measure grams of water, is that 100 grams of water is the same thing as 100 milliliters of water, and that is because water has a density of 1 gram per milliliter. So if you have 100 grams, that means you have 100 milliliters. Okay, so don't let that confuse you. But what a solubility curve shows you is it shows you all of these curves that you have. Let's see if I can get a highlighter. So all these curves that we have here, so like this curve here, let's say for instance KNO3, those curves, these represent your saturated solutions. So what this tells me is like, for instance, for KNO3, it is telling me that if I want to make a saturated solution of KNO3 at 50 degrees Celsius, because that's my X, that I'm going to need, in order to make a saturated solution, I'm going to need 80 grams of KNO3. So I have 100 milliliters of water. It's at 50 degrees Celsius. I've measured out 80 grams of KNO3. I've added that to my water and I've stirred it. It's all dissolved. So the curves that you see, these are your saturation curves. So that tells you at what point is that solution saturated. So you can be asked questions about, if you have 80 grams of KNO3 at 70 degrees Celsius, what type of solution do you have? You can be asked questions like how much solute do you need at 90 degrees Celsius to make a saturated solution of KCl. You can be asked questions like that. So you can read the stuff on the right-hand side, but it's going to basically tell you what all I am telling you. So I'm going to go ahead and scroll. So right now, we're on this part right here where it says, if the temperature and the amount, so remember it's X and Y, it's just like any other graph. So temperature and amount, because you're looking at both of those. Where they intersect, whether it's on a line, above, not on a line, but on the line, above the line, or below the line. And this is specific to your actual substance you're looking at. So you'll notice that all of your lines are labeled. Okay. So make sure that when you are looking and you're answering questions, that you are looking at the correct line. So all the lines are labeled. Okay. If the temperature and amount intersect on that line, like it did here for the 50 degrees Celsius and 80 grams, that is what we call a saturated solution, okay? Which means it has the exact amount it's supposed to have. If, however, let's say I had dissolved 120 grams of KNO3, so I'm up here. So still 50 degrees Celsius, but now I had dissolved 120 grams. I have dissolved more than what I should. So it's higher than the saturated. This would be called supersaturated. Okay. So that is a supersaturated solution. So I'm going to just put supersat. Okay. The way you make a supersaturated solution, and we'll see this, is that you heat up. So I actually had to heat up the solution higher than 50 degrees Celsius in order to dissolve completely the 120 grams into my solution. But then what happens is I set it aside and I let it cool. And then so when it cooled, none of it came out of solution. So it's still in that solution. So that is why it's super saturated, because you have more in there than what you're supposed to. Okay. And that's also something you should have read about in your Actively Learned articles. If I said, all right, well, I only have, I'm trying to make a saturated solution of KNO3 at 50 degrees, but I only have 20 grams of KNO3, so I'm right down here. Notice how my saturation point is at 80. I don't have enough KNO3 to make a saturated solution. So this is like saying I don't have enough sugar to make sweet tea. So I only have a little bit of sugar. Well, those of you that really like sweet tea and really hate unsweet tea, you know if you don't have enough sugar, it just doesn't taste right. Okay, so if we are below our saturation line, that is called a unsaturated solution. So I'm going to just call it unsat. Okay, so that's how you can determine whether you got a supersaturated, saturated, or unsaturated solution. All right. What I'm going to say is if you dissolve 50 grams of Ki in 100 grams of water at 60 degrees Celsius, what type of solution will you produce? So you're either making a saturated, unsaturated, or supersaturated solution. Once again, remember, do not let this 100 grams of water confuse you. That's just how we measure solubility. It's the grams of solute per that 100 grams of water. In this case, we're going to have 50 grams. So I'm going to go ahead and put my mark with 50. So we have 50 grams, and it's going to be 60 degrees Celsius. So I'm going to go ahead and put my mark here for 60 degrees Celsius. So 60 degrees Celsius, 50 grams, puts me right here. So that is where my intersection is. And it's asking me what type of solution is it going to be. I'm specifically looking at Ki. So if I'm looking at Ki, so where is my Ki? Here's my Ki. So there's my saturation line. Here's our point way down here. Is it on the line, above the line, or below that line? So it is clearly below the line. So since it is below the line, it is what we would call a unsaturated solution. So that one would be unsaturated. Okay. I'm going to go ahead. Would I need to add, which means I need to measure out more solute, or do I need to subtract, which means I need to measure less solute, if I want to produce a supersaturated solution of NH4Cl? So far I've measured 20 grams at 30 degrees Celsius. All right, so 30 degrees Celsius, 20 grams. Here I am right here. I am specifically asking about NH4Cl. So just to help us out, NH4Cl, there is our line for NH4Cl. So right now we are below the line. So since we are currently below the line, that means we are currently an unsaturated solution. So because we are unsaturated and we are trying to get to supersaturated, which means we got to go past the saturation point. So I'm not even enough, I don't even have enough to be saturated yet, because in order to be saturated 30 degrees Celsius for an H4Cl, I would need at least 40. So I don't even have at least 40. So therefore, since I don't have enough, since I don't have enough, that means that I need to measure out more. So that means I'm going to need to add more solute. Okay? All right, so question number 3. Let me go up here and do says, as the temperature of a solution of NH3 increases, the solubility of NH3 does what? So we're specifically looking at NH3. So I'm going to go ahead and highlight my NH3. So here's my NH3. So as that temperature of NH3 is increasing, notice down here on the bottom, our temperature gets hotter as we go to the right. So my temperature is increasing, but what do we notice? So as we start at 90 grams, we're at 0 degrees Celsius. And as I get hotter, so as I get to 100, I'm at like 5 grams. So my temperature has increased, but the amount soluble has decreased. So the solubility of NH3 as the temperature increases, specifically for NH3, the solubility is going to decrease. Okay, so this is looking at your slopes. Notice that most of these substances have what we call a positive slope, which means they slant upward or slope upward, and that means they're increasing. Okay, if you have a downward slope, like here, so you got this downward slope, and we have the NH3, that means you're decreasing. That's a negative slope. Okay. All right. So now Moving on to question number 4. What is the most soluble substance at 80 degrees Celsius? So 80 degrees Celsius is here, and we want the most soluble. So if it is going to be the most soluble substance, that means that it is going to dissolve the most solute. So we want to start up at the top because we want the most soluble. So this is our 80 degrees Celsius. So we're going to start at the very top. So the very first line that we cross is this one right here, which is NaNO3. So therefore, at 80 degrees Celsius, because you have to go based off what you can actually see on the graph, NaNO3 is going to be the most soluble substance. Okay, question 5, we don't actually need to erase, so I'm not going to. Question 5 says, what is the least soluble substance at 30 degrees Celsius? So now we're down here. We want the least soluble substance. So because we want the least soluble substance, that means it's not going to dissolve very much at all. So we're going to start at the bottom of the graph. So the first one we're going to run into is right there. That's the first line we cross, and that is going to be the cesium. So cesium sulfate, Ce2SO4 3. All right. So that is your notes on solubility curves. That is examples of questions you are being asked on the practice that you have. So what you're going to want to do now is you're going to go to the link where it says solubility curve worksheet. It is a Google form assignment. There's like 15 questions on it. So you'll answer them, submit your form, go check your Gmail account. Once you go check your Gmail account, you'll have a do not reply, like an email from do not reply. It's from I got Flubaru again. We've done assignments like this before. So you will see what your grade was that you made on it. If you did not make a 100, you will also see the questions that you got incorrect as well as what your original answer was. You can then go back into Schoology and go back to that assignment again, and you can submit it as many times as it takes for you to get a 100.